Screen space ambient occlusion is a technique that approximates the loss of ambient light a fragment receives as the result of nearby geometry. Fragments that are surrounded by geometry are said to be occluded by them and should be shaded darker as a result. For an example, notice in the right image how the part of the wall that is directly behind the telephone booth is darker than the rest. SSAO requires several rendering passes, so it fits best within a deferred shading pipeline. As in all deferred pipelines, the first pass, known as the geometry pass, populates the frame buffer with relevant fragment data to be used in later passes. Here, we store each fragment's position, normal, and ambient color. Positions and normals are in view space to make later calculations easier. Next is the primary SSAO pass. Using data from the geometry pass, we calculate how occluded each fragment is and output this value to a grayscale texture. This is done by sampling nearby positions to the fragment and determining if these positions are covered by geometry. In order to maintain high performance with acceptable results, we keep the sample count low but randomize their positions to prevent banding. An unfortunate consequence of using randomized sample positions is that the results end up very noisy. The next pass is a simple blur to dampen this noise and even out the results. The final pass calculates lighting and outputs the final image of our scene. The only notable difference in our lighting shader is that we now adjust the amount of ambient light each fragment receives based on the occlusion map we generated in the previous passes. For the purposes of this demo, ambient light will be the only lighting applied to our scene. Notice how after applying ambient occlusion, the areas behind curtains and pillars become much darker and there is a greater sense of realism. Here is a more extreme example. Before applying ambient occlusion, the scene has no depth and much of the geometry appears just as blobs of color. And the results speak for themselves. While not physically based or academically rigorous, screen space ambient occlusion is a fantastic method for approximating global illumination in real time. Thank you.